Okay, welcome back. This is the third video of the Analyzing PowerShell Payloads series. In the first episode, we went over a standard run-of-the-mill encoded PowerShell payload, and we learned about the from base64 string keyword and the Gunzip compression keyword and how to analyze that data in CyberChef. In the second video, we built upon that same style of payload, except this one had an XOR function built in there to add an additional level of obfuscation. And so we went through the XOR function in CyberChef. We're going to keep this train moving along, and we're going to look at another payload that's formatted very similarly, although it adds a little bit of trickery in there. So just like the last ones, we're going to be building upon that. We're going to add an additional level of obfuscation, but have no fear, fam. CyberChef to the rescue. Okay, so if you've seen the other two videos, you know that we know what this is, right? This is old news by now. PowerShell is running and it wants to run hidden, doesn't want anyone interacting with it. And then we have our from base64 key string. So we know based on what we've learned in before that in between the parentheses is base64 data. And then we run into a new keyword, which is .replace. So in PowerShell, .replace is pretty self-explanatory, but it's just a string match replace. So it's saying for every exclamation point, replace it with nada. So in this one, there's just one exclamation point at the beginning. This is a very simple replace function. Obviously, you could just delete it, but I'm going to show you how to actually do it through CyberChef, although because sometimes you do see some pretty elegant replace functions. And so we want to know how to actually process that as we go through there. And finally, if we go through there again, we have our other keyword that we know about before, which is gzip. So we know that we're going to do a gunzip on this data. Okay, so just like the other ones we learned from video 1, we always start at our obfuscated data and work our way out. So the first function that's applied to the obfuscated data is the replace function. So CyberChef has just replace, and we're just doing a simple string replace, which is find every exclamation point and replace it with nothing. Okay, so the next thing we want to do is just like we've learned in the other ones, we've done this. Hopefully this is becoming like second nature to you by now. We're going to do our regular expression, select our base64 data, change this to list matches, and then we're going to do from base64 and then gunzip, because remember we saw our gzip compression keyword. Okay. And boop. And then we see again, okay, here's that here's like I mentioned, you're going to run across, as you look at this, you're going to run across this all the time. Here's a little bit of obfuscation, right? They've broken up that set strict mode version 2. This is to kind of get away from, if you remember in the last video, I mentioned like, oh, when you see set strict mode version 2 and do it equals the @ symbol, that's an indication this the don't kill my cat payload, and some automated security tools will see that and use it, string match and flag that. So they're just trying to get by that. And it's to be honest with you, that's what the replace function in an original payload is normally trying to do, is they just flip like one or two things to get through any sort of automated detection, because they're not, it's typically they haven't been smart enough to actually read through and do the replace. So it's not, it's just it's a little bit of trickery. It's nothing that human eyes can't be like, okay, well, I know what that is. All right, so we have our don't kill my cat payload. We already know what this is. Again, we've already gone through. We know that we're looking for our next thing here. Now, this looks a bit different from before, but that's okay. If you remember video 1, 2, we had a from base64 in there. In this case, we don't. Whoever made this one kind of helped us out by, by context clues. We can see that this is defined as hex data. But really what I've noticed is our keyword here is when you see this char byte and then you have the 0x indicated in there, that's usually been the keyword where this doesn't change across. Like they could make this variable name whatever they wanted. But this piece right here, I haven't seen that change all that often across various payloads. So And then finally we already know about this keyword bxor. So we know we're doing our XOR with our key of 35. But first we got to start at our obfuscated data and work our way out again. And I'm going to show you how to do this. This is rather simple. Again, we're going to do our regular expression again. In this case, all we have is, we don't even need this data because all it is letters and numbers. And we'll list that out. And then fortunately, CyberChef has what we're looking for, and we do a from hex. And it's okay. This drops in there because remember, we still have our XOR function that we got to apply. So we do XOR, change this to decimal because it's a decimal number, and then we change our key to, oh, not 43, 35, and boom. So this one looks different from before. You remember through the first two payloads, we saw a user agent string and they were connecting back to an IP, and then one was connecting to a domain. In this one, we don't have a user agent string, but we have this //dot/pipe and then status underscore and then ed07. Now, what this indicates is that it is opening up a named pipe. You will see this whenever, if someone's using Cobalt Strike and they connect to a machine using the SMB beacon, excuse me, so they're proxying their C2 traffic through another compromised host, and they'll, connect, try to pop this box, and they'll open up a named pipe and then do everything over SMB. You'll also see it whenever in the standard kind of privilege escalation functions that are built into Cobalt Strike and Meterpreter, whenever you try to elevate up to system, and it does that through installing a new service, the payload will decode to a new named pipe. But what's important there is now you have some context to what is happening. So if I saw this, then I can, the first thing I'm thinking of is either this came from another machine on the network, or someone was already on this machine and now they're trying to escalate what privileges. So that's tactical intel. More, intel is more than just IPs and domains and hashes and stuff. Now we have some context behind what this was actually trying to do to help guide the rest of our investigation. So that is how you extract tactical information from an encoded PowerShell payload that's using a hex array using CyberChef. The first three were pretty, self-explanatory. They built on the same sort of style of payload. In the next episode, we'll be changing things. We'll get out of, we'll stay in CyberChef for the first part of it, but we're actually going to dive into how to compile some shellcode and do some analysis on it without using a debugger. I'll show you the easy way to do it. That's the way that I learned.